I'm gonna talk to as many as I can before I fall asleep. For some of these, I might just give a quick game plan of how you would solve it. And again, this is the review for Unit 5 assessment. Hope you're having a GR number 8 day and that the sun's a shining and that you don't have any allergies to pollen because the weather's been pretty nice. This one, light work. You have a radius of 5 if you really think about it from here outwards. And that would be the shaded circle, but you want to deduct this middle one, which has that circle with radius of 3. So do pi 5 squared and deduct pi 3 squared. What's that get you? Is that 16 pi? Units squared, of course, you already know. And here, this is an equilateral triangle inside of a square. This is kind of an interesting problem. You could take the idea that this is a square, 6 by 6, terrible square, 6 by 6 square, and just deduct that equilateral triangle in the middle, where, yes, you're able to say that this is 666. And you might be curious, how can I get the height of this? Well, if you bisect this, you know that for an equilateral triangle, all of these should be 60 degrees here, here, here. But if you bisect it, that means this is 30. So boom, you got a special right triangle on your hands, hypotenuse of 6 across from 30. That's half of the hypotenuse. So this should be 3. And this is 3 root 3. So this is pretty much going to do 36 minus 1/2 base of 6 times height of root 3. Because remember, this is the base for the whole triangle. And we know the height's 3 root 3. So I think when you boil this all down, this ends up as 36 minus 9 root 3. And of course, units squared. How are you feeling so far? Pretty good? Good. I like the hexagon problems a lot. There are a variety of approaches you could take for this. I've seen an approach where someone tried to find what that would be. The approach I'm going to take is a little bit different. I know that this is a 6-sided figure, and I know that these are all congruent sides. And so there's a formula that says that you can take the number of sides of a figure, deduct 2, and then multiply that by 180. And that will dictate how many degrees are in the whole thing. So if you do that, this is saying that you have 720 degrees to disperse amongst these corners here, 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 a key, and there. And if you have 6 angles, you can divide this by 6 and say that, well, each of these little angles that I just sketched out are going to have to be 120. And since this is an isosceles triangle, the shaded region, you're allowed to say that these bottom 2 angles should be congruent to each other. If you run some quick math, you can say that this is 30, this is 30, and you can say that again, these are 6 and 6. And so how does that help you? Because you know that if you cut this in half, what kind of triangle is now being created? Cert, 30, 60, 90, where you know that your hypotenuse is 6. So across from 30, that's half. And you know that across from 60, that's now 3 root 3. So really what you're doing is saying that you have 3 of these triangles with height of 3. And what's the base now going to be for one of these bigger triangles? Hopefully you're saying 6 root 3. This is not a blooper, because think about this. If this is 3 root 3 from here to here, this also has to be 3√3 from here outwards. So at the core of it, you're just taking 3 areas of triangles with height of 3, base of 6√3, capiche? And if you look at this closely, you can also say that this is the same song and dance, isosceles triangle with base of 6√3. And that means that this is also 6. So this one's actually super simple because you can just say base of 6 times height of 6√3. So 6 times 6√3, getting you 36√3. Capiche? Make sense? Sound good? 2, you did that on the quiz, so you should recall how to do that. Quick summary, you have those 2 triangles that are facing you. You want to add on the 2 sides here and also there. You know what I mean? And then you have this bottom here, which should be a 16 by 11. And then boom, I think that's all 5 sides that are showing, right? Yeah, so I'll leave that one to you. You may benefit from getting the height of this, because if you look closely, you can get the height of this because it has a hypotenuse of 17 and a base of 8. That can help you get out what the height's going to be. How much cardboard's needed. This is roughly saying get the surface area. So this is not too bad. If you want to sketch out more of what you know, you can do that. Sketching out more heights, maybe even taking this down so you know what these are. So what do I see? I see 2 versions of the 6 times 7. I see the front and back version of 6 times 8. And then I see this base, which is 7 times 8. Just one version of it. So run all that arithmetic, let it rip. This is a 30, 60, 90 with, and think of this bird's eye view. Don't be afraid to redraw these if you need to. Draw this as 6. This is 30 degrees. This is 90. This is 60. So you can say your hypotenuse is 12. You could say that this is 6√3. And so this is open top. So really you only need to accommodate this side that's here, which is 6 times 8. You add on this pane here, which is 8 times that 6√3, which again, you got from the bird's eye view. This is 6√3. You then have that outer facing area where we know that the width is 12 and that height is 8. And then you have that triangle at the bottom, which we just broke down. And we said that that's going to be height of 6, width of 6√3. So do 1/2 base times height for that. And I guess just because I'm here and just because I have seen this problem a little bit, I will boil down this arithmetic for you. And then I'll leave it up to you to combine. Okay, capiche? Sound good? Doing okay so far? You know these answers are on Blackboard, right? For you to check. This is a Pythagorean triple in the middle, hypotenuse of 10, leg of 8. You could even run Pythagorean theorem if you wanted to. But this is roughly going to say that your diameter of this is going to have to be 6. And so how does that help? You can then say that the radius is 3. Determine the total surface area and the volume that I will, yeah, I'll leave that to you because at this point in the game, you're really just trying to assess a cylinder with radius 3. They just throw that triangle in the middle to make it a little vague for what it is. Maybe that's a little mean, but this is really the image you want to assess. If that helps. A few things you can sketch out here. I'll leave it up to you which way you want to start, but I'm personally going to start assessing this cone on the right. go look up that formula for the cone. I think it's 1/3 base times height, something like that. So you're able to say that this radius is 3, and then this is actually a Pythagorean triple, 3, 4, 5. So the height of this cone is 4. So if you need more of a bit by bit breakdown, you can say that the radius of this is 3, but your height's 4. You then have this cylinder in the middle, this cannoli. So get a hold of that, because you know that again, the radius is 3. And how far out does this expand? I'm curious. Well, this is definitely 3 for this little like bubble of sorts, because you know the diameter is 6. So that means that if this is a total of 17, you've already accommodated for 3 and 4, that means that this is going to be width 10. So you can do a quick pi r squared times 10. You can do volume of the cone with that. And then you can get half of the sphere. So that little bubble that's kind of poking out. Semisphere. So get the half of the semisphere. And then just add those up. I don't think they're too bad. This is being vague that it's a 30, 60, 90, but it is, because you can then pop in and say that this is 60. So the hypotenuse is 12 across from 30. That's going to be half. So this is 6. So really you're finding a cone's volume with radius of 6 and height of, you guessed it, 6√3. So there you go. The key thing here is to know the special right triangles. Those are going to help you out a lot. You're designing a box that holds this amount of water, square bottom, open top, quick sketch. All these sides are congruent because it's a square bottom. You can then sketch out the rest of these lines. I think visualizing this is huge, so do not be afraid to draw these out. So let's call this S for a side, because this should be a square, and there's some height, and this is again an open top. So they kick you the volume, which is helpful, because that's going to be the base S squared times H, claiming it's 500. So far we've got one equation. And to do the least amount of glass, it's probably going to deal with surface area. So you can make a surface area equation. That's going to be S squared plus 4 versions of S times H, because you need to account for it. This side, that. And so that'll be your SA. You can then solve this for H ideally, claiming that H equals 500 over S squared, because no matter what, this property should hold. You can then take all this, put it in place of H. And so in a moment, we're going to graph out this S squared plus 4 versions of S times 500 over S squared. And if you want to simplify this, kudos to you. I think it's what, like 2000 over S, but we'll graph this and see if we can figure out where the least amount of class is. All right, so we're here at Desmos. Pardon my use of X, because previously I was using S, but that's okay, because this is now graphed out. And this is saying that if we have our S coordinate for the box at 10, and I'll make a note of this. So if the side of the base is 10, we'll produce a box with surface area of 300 feet squared. And you could also go back and say that if you wanted to solve for what the height's going to be, you could do 500 over 10 squared. And so that's going to say that the height is 5. Each makes sense. Again, this is accommodating that the volume needs to hold 500 feet squared, and you know that the base is a 10 by 10. And this is going to kick back the least amount of glass that you would have to use to make that condition work. Capiche? Desmos is pretty helpful for these. Be careful making your equations because that's a pivotal thing. We'll see you on the next problem. I have this problem already done, but you have to take the perimeter, which you know it's 18, but you want to take this slowly because really you just want to get how long this length is going to be, which is 1/2 2 pi times this radius, which is, this is really just pi r to get this top portion. And then if you wanted to take that walk around, you would have these two versions of the height to accommodate. So hence plus 2h. And then down here, this is really the diameter. So you can call it 2r. You can then solve for the variable of your choice. In this situation, I solved for r, but personally, I think solving for h would have been a little bit easier, but that's okay. You can then push that into your area equation, which is doing, what is this? 2 versions of r times h. This is for that rectangle, then 1/2 pi r squared, which is the area of that semicircle at the top. And so if you then take this equation, 18 minus 2h over pi plus 2, you put that in place of r, you graph this out, don't forget to square this, you'll eventually get what h is going to be, and you can use that to help you figure out what the dimensions are going to be. The domain is going to be from 0 to infinity because you don't want to like have negative values in there. But the key thing is that, or no, it's actually not 0 to infinity. We should actually look at this. We'll graph this out shortly. Give me a second. All right, so this is graphed out now. Again, instead of, what was I doing? Instead of h, I'm using x. So this is going to kick back the height of this figure. We see that our domain is going to be with 2 roots, potentially, but we really only want to include from 0 to 9. So let's make a note of that. For this interpretation, our domain is from 0 to 9. We see that there is definitely a max point, which is good. So this is going to say that our max is going to occur at 22.684. And again, we are measuring the area, and that's going to be in feet squared. What else can we say? We said that this is going to be measuring the height. So this is going to be a height of 2.52. And is it exactly 2.52? That's interesting. There's no third decimal. Okay, that's fine. And then we can figure out what our radius is going to be if we go about doing the 18 minus 2 versions of this, pi plus 2. So let's evaluate that real quick. Set of x, I'm putting 2.52. Is that right? Is that correct? 18 minus 2 versions of that, pi plus 2. Let's think on this for a moment. Yeah, so interestingly enough, this does work. And this is going to say that our radius is also 2.52-ish, which means that the diameter is 2.52-ish. So therefore, the width, 2-ish. Interestingly enough, interesting little diagram that's created. I will leave this in the comments, or the description rather. Yeah, I'm going to comment on my own video with a graph. Brilliant.